Hello friends. In the last video we have discussed Born-Haber cycle, constitution of a Born-Haber cycle, that is formation of NaCl. NaCl is formed from Na plus and chloride ion, and how Na plus ion is formed. Na plus ion is formed from solid sodium. On sublimation it is converted to sodium gas, then on ionization produce Na plus ion, and chlorine on dissociation produce chlorine atom gain one electron and form chloride ion. Next Na plus and Cl minus combine and form NaCl solid, and the energy liberated, it is called lattice energy. This is the final equation of delta H formation of NaCl. Today we will discuss utility of Born-Haber cycle. Born-Haber cycle is useful in calculating any energy term involved in the cycle, provided all other energy terms are known. We have seen that the formation of NaCl, the equation is NaCl formation. The energy terms are sublimation energy, ionization potential, bond dissociation energy, electron affinity, and lattice energy. So here Born-Haber cycle is useful in calculating any energy term involved in the cycle, provided all other energy terms are known. So lattice energy, electron affinity which is difficult to calculate for many elements. So from Born-Haber cycle we can calculate electron affinity of that rare element, and lattice energy also we can calculate from Born-Haber cycle. Another utility of Born-Haber cycle is that Born-Haber cycle is useful in understanding the stability of many ionic compounds. For example, magnesium oxide. Magnesium oxide is very much stable. It is formed from magnesium ion and oxide ion, and huge amount of lattice energy is liberated. As huge amount of lattice energy is liberated, so magnesium oxide is very much stable. So it is one of the utility of Born-Haber cycle. Next we will discuss today lattice energy. Lattice energy, that is the amount of energy liberated when 1 mole of the ionic crystal is formed from the free gaseous ion from infinite separation. Means here if the formation of 1 mole of magnesium oxide, from the corresponding magnesium and oxide ion, the amount of energy liberated, this liberated energy is called lattice energy. Keep in mind that when 1 mole of the magnesium oxide or 1 mole of ionic crystal is formed from the corresponding ions, the amount of liberated energy, this liberated energy is called lattice energy. Lattice energy, it is mathematically expressed as lattice energy U. Lattice energy, it is mathematically expressed as U equal to minus Na Z plus Z minus square by R0 into 1 minus 1 by N, where N is Avogadro number. N is Avogadro number. A is called Medullang constant. A is called Medullang constant. Z plus Z minus, that is charge of the cation and anion, and R0 is the equilibrium distance between the adjacent ion. R0 equilibrium distance between the adjacent ion, and N is called Born exponent. So here in the equation of lattice energy equal to minus Na Z plus Z minus square by R0 into 1 minus 1 by N. N, that is Avogadro number. A Medullang constant. Z plus Z minus, that is charge of the cation and anion. R0 R0 equilibrium distance between the adjacent ion, E electronic charge, N near bond exponent. So from the figure it is clear that if Z plus Z minus is high, if Z plus Z minus high, then lattice energy will be also high. U is proportional to Z plus Z. If charge of the ion, that means if magnesium ion, oxide ion, if we consider aluminum and oxide ion, so aluminum ion will be 3 plus. So if charge of the ions, whether cation or anion is high, then lattice energy liberated, the liberated lattice energy will be also high. Again, U is inversely proportional to 1 by R0. That is, if the equilibrium distance between the ions, if the equilibrium distance between the ions is high, then lattice energy liberated is low. Or if the equilibrium distance between the ions is low, then lattice energy is high. For example, we can consider, suppose a question given, cesium fluoride, cesium chloride, cesium bromide, cesium iron. What will be the order of the lattice energy? What will be the lattice energy order? Now here you can see that cesium fluoride, cesium chloride, cesium bromide, cesium iron. So cation is same, cesium. So lattice energy depend on the anion, F minus, Cl minus, Br minus, I minus. Now here Z minus is same. So Z plus Z minus, that is in all cases cesium plus 1 and halogen X minus. So charge is same. So lattice energy order cannot be determined from the charge of the ion. So how lattice energy order we can write? We can write lattice energy order from the R0 value. Down the group we know that radius increases, R0 increases. So R0 increases, down the group R0 order will be F minus less than Cl minus less than Br minus less than I minus. So down the group radius increases. So radius increases. So we know that lattice energy U is inversely proportional to 1 by R0. So as down the group radius increases, lattice energy decreases. So here you can see that cesium is same, cation is same, depends on the anion. So as the size of the anion increases down the group, so lattice energy decreases. So lattice energy order will be, the correct lattice energy order will be cesium fluoride, cesium chloride, cesium bromide, cesium iodide. Question will also come from the group 1 elements, generally group 1, group 2 and group 3 elements. Next, today we will discuss another new topic, that is solvation energy. Solvation energy. Solvation energy. So solvation energy it is defined as when a gaseous cation or anion react with a solvent in the liquid state, there is a liberation of energy, and the liberated energy is termed solvation energy. So solvation energy for gaseous ion, suppose Mn plus solvent, solvated ion, plus energy, and the liberated energy it is called solvation energy. So when a cation or anion in gaseous state reacts with a solvent, the cation or anion will be surrounded by the solvent, so that is called solvated ion, and solvated ions, and the amount of energy is liberated. This liberated energy is called solvation energy. If the solvent is water, solvated ion plus. If the solvent is water, then the amount of energy liberated, it is called hydration energy. If the solvent is water, then the energy is called hydration energy. So today we have discussed Born-Haber cycle, utility of Born-Haber cycle. One of the utility of Born-Haber cycle is that lattice energy, electron affinity can be determined. So lattice energy expression, mathematical expression, lattice energy variation, lattice energy depends on charge and radius. Some questions, typical type question of lattice energy order. Here cesium halide series given, lattice energy order. Another solvation energy and hydration energy. This term is important, hydration energy and solvation energy. Today we have discussed this. So if you like my video, please like and share the video, and please channel को subscribe कीजिए so that I can make more videos, more interesting videos. And if you like, if you want to know more, then you can comment also. So thank you once again. Please subscribe my channel. Thank you.